All right, so let's see if we can take this the whole way home. From the top. Trigonometric substitution, we have a radical of square minus square. Triangle, always in the same orientation. Label the hypotenuse first. In this case, if it's subtraction, it's whatever is this first, or the square root of this first piece, that's x. As much variable vertical as possible, so that's going to be the radical. And then whatever is left over, as much as possible, this leftover is going to be, typically it'll either be the constant or it'll be the radical if it's that. So here we go. Wonderful. So now we got to choose. It's not very neat. Some of the guys probably can't see that, so pardon me, boys. We'll do the... Here we go. So let's see. First, choose the function that does not involve the radical and no variables in denominator. So we've swum this before. So we can choose secant of theta is equal to x over 5. The thrust of this first choice is to create the x so that we can create the differential. So 5 secant of theta is equal to x. The derivative, that's secant theta. 5 secant theta tangent theta d theta is equal to dx. So that part's correct. And then choose the function that does involve the radical, no variables in denominator. So that's tangent of theta is the radical and over 5, and move the 5 across. So 5 tangent theta is equal to the radical. And as soon as you have the radical, as soon as you have the differential, the substitution is exact. So substituting, and we followed this path in the previous example or previous video here. What do we have? We have the radical. The radical is 5 tangent theta. We also have dx. Remember, the differential is numerator. So this is 5 secant theta tangent theta d theta. And then in this particular problem, we have x. If we had x squared here, then you would square both sides of this, right? If we had x to the third, you would cube both sides of this. So we have x, and x is equal to 5 secant theta. Simplify. Let's see, 5s go, secants go. This is 5 times the integral of tangent squared. And we can convert that into basic form. Proceed as we did with the previous section. That's why it's so vital that every one of these sections, each one builds on the other, so that if you're unsure of the trigonometric integrals, that's not going to help you when you get to trigonometric substitution. And if you don't know your basic forms, then you're really out in the cold. So anyway, what do we have here? Tangent squared converts to secant squared minus 1. And now the reason for doing that, of course, is we know secant squared is a basic form. Right? So these are both basic forms. That's tangent, and that's the power rule. So what we're left is 5 times, right? The integral antiderivative of secant squared is tangent theta. And the antiderivative of a constant is you reattach the variable. And then what's always left to do, once you've done the antiderivative, notice, look, the only calculus in this entire stretch, the only actual calculus work really in this entire stretch in terms of calculus computation is right there. That's it. All of this is getting your ducks in a row. Then you work the trigonometric integrals, and that's just changing the form of the expression. This step right here is the actual calculus. And now we go back to the original variable. And how do you get back to the original variable? You go back to these choices and the triangle if needed. What is tangent? We have it sitting right here, tangent theta. Tangent theta is the radical over 5. So this is 5 times, we have the radical, and then what is theta? Theta we can get from right here. Right? Theta, we know that 5 secant theta is equal to x. And this is very often, whenever you create the variable theta, you go back to this expression and you back solve this line, you back solve here for theta. Take inverse secant of both sides of this expression. Inverse secant. If this had been sine theta equals something, then you do inverse sine. If this is tangent theta equals something, it's inverse tangent. So whatever this expression is, do the inverse function. Theta is secant inverse of that expression. And you're out. If you want to try to simplify that and change the form, well, God bless you. There's no way in the world this is the same as the textbook. The textbook probably distributes the 5 and cancels it and some other things. But as soon as you find the antiderivative, as far as I'm concerned, you're out. You're good. So that's the procedure. And what's left to do is I'm just going to go through about, I got 1, 2, 3, 4, 5, or 6 examples of this just to show you the various scenarios to practice this procedure.